Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X published on July 31st, 2025, just a couple of days ago. This paper introduces a new model for 3D reconstruction that improves quality by about 3 decibels in peak signal-to-noise ratio, or PSNR, which is a key metric for image quality, all while using less than half the computation time. The paper is titled iLRM, an iterative large 3D reconstruction model, and it achieves this with a really clever iterative architecture. It's designed to solve a major bottleneck in creating 3D scenes from 2D images, where existing methods get bogged down by high computational costs as you add more views or increase image resolution. And as you might expect, it's already making waves on social media. One of the authors, Janusz Patas, shared a post on X highlighting the work. The post includes a key excerpt from the abstract, mentioning that the model generates 3D representations through an iterative refinement mechanism, and it comes with a video showing the model in action. It's already picked up pretty solid engagement for being so new, with over 100 likes just a day after the paper dropped. People are clearly excited about this approach. And this first figure really visualizes why people are so excited. At the top, you can see this iterative refinement in action. The image starts as a noisy cloud of points at layer 6, but by layer 12, it resolves into a sharp, fully formed 3D scene. The diagram below shows how. It begins with viewpoint embeddings, which are compact digital summaries of each camera angle. These are repeatedly updated with information from the multi-view images before a final 3DGS head generates the output. This output is a 3D Gaussian Splatting representation, which is essentially a collection of fuzzy, colored 3D points that efficiently build the final scene. Building on that, this next diagram really breaks down the architectural magic that makes the model so scalable. Okay, so on the far left, you see the old method where every high-resolution image token, which is a small piece of the image data, has to interact with every other token. This is computationally a nightmare. The key innovation is a 2-stage attention process. Attention is just a way for the model to focus on important parts of the input. First, they use cross-attention, where each viewpoint embedding only looks at its own high-resolution image to pull in fine details. Then, they use self-attention, where all the low-resolution viewpoint embeddings talk to each other to share the bigger picture. This clever split is what makes the whole process so much faster and more efficient. Moving to the results, this figure really puts that efficiency to the test on the real estate 10K dataset. What we're looking at is a qualitative comparison of novel view synthesis, which is the task of creating an image from a new camera angle that wasn't in the original photos. On the left is the target view, which is the ground truth. You can see that our model, iLRM, especially when using 8 views, creates an incredibly sharp and realistic image. The competing models, however, produce much blurrier, distorted results. This really drives home how using more views, which the new architecture allows, leads to a massive leap in quality. And this table gives us the hard numbers to back up that visual intuition, this time on the DL3DV dataset. We're looking at metrics like PSNR and SSIM, where higher numbers mean better image quality, and LPIPS, where lower is better. The key takeaway is scalability. Competing models use 6 views, but our model, iLRM, can use up to 24 views, and when it does, it achieves a nearly 4-point jump in PSNR with comparable reconstruction time and much less memory. This shows it's not just better, it's more efficient at using more data to get that better result. Okay, and this table then details the performance on another major benchmark, the real estate 10K dataset. Again, we see the same pattern of superior quality and efficiency. The best version of the new model uses 8 views and achieves a PSNR of over 31. That's a huge jump of about 3 decibels over a top method like depth splat. And here's the kicker. It achieves this quality in less than half the reconstruction time. It's also incredibly efficient with its scene representation, sometimes using half the number of Gaussians as competitors while still producing better results. So to really understand why the model works so well, the authors conduct what's called an ablation study, which is where they systematically remove key parts of the model to see what breaks. And the results here are super revealing. Removing token uplifting, which is their trick for aligning low and high resolution information, causes a small dip in quality. But look at what happens when they remove self-attention, the part that lets all the viewpoints share information. The performance absolutely tanks. This proves that self-attention is the critical ingredient for integrating the global context and achieving that high-quality reconstruction. So in conclusion, iLRM tackles the major bottleneck of scalability in 3D reconstruction. Its two-stage attention and iterative refinement allow it to efficiently use more data to build stunningly realistic 3D scenes in a fraction of the time. That's it for this episode